Hi, my name is Samuel Paul. My metric ID is MA22145. In this presentation, I will be talking about FMEA, Failure Modes and Effects Analysis. First off, what is FMEA? So FMEA stands for Failure Modes and Effects Analysis. It is a structured, systematic approach for identifying where and how a process or product might fail and assessing the impact of different types of failures. It was first developed by the US military in the 1950s, and it was then adapted in high reliability industries like aerospace, automotive, and medical devices. It has become a staple tool in Six Sigma, particularly during the improve and control phase of the DMIC cycle. FMEA is a quality tool that is very commonly used in the industry. Why? Because it is the most effective tool for risk prevention. Instead of fixing the problem, it prevents them entirely. So by using FMEA, you prevent costly defects, prioritize issues using RPN, risk priority number, improve reliability and customer satisfaction, and you make better decisions during the improve and control phase. Now there are a few types of FMEA. The first is design FMEA, which focuses on identifying potential failures in the design phase of a product or component. And then the second is PFMEA, which is process FMEA, which is used to assess risk in manufacturing or assembly processes. The third is SFMEA, which is system or functional FMEA, which is applied at a broader level to examine interactions between subsystems or overall product functions. Now these types of FMEA each serve different stages of product development or process management. When do you use FMEA? You use it early on, preferably during the design phase or while planning a new process. This allows engineers and quality teams to anticipate potential risk and mitigate them upfront. It's also valuable in improving an existing process, investigating recurring quality issues, launching new products or systems, making changes to existing processes or equipment. So among the benefits of FMEA are failure prevention, where it helps identify potential failures before they occur, and in this it gives cost reduction by avoiding defects, safety and reliability, especially in critical sectors like automotive, aerospace, and healthcare. Better decision making, because FMEA provides a structured, quantitative way to prioritize risks and allocate resources more effectively, as well as continuous improvement as it integrates with Six Sigma's DMIC cycle. There are some key terminologies that are used in FMEA. Number one is failure mode, which is how a process or product can fall. Effect is the impact of the failure on the system. Cause is the root reason the failure might occur. Severity is how serious the effect is. Occurrence is how likely the cause is to happen. Detection is how likely the failure will be caught. RPN is the equation, severity times occurrence times detection. So here is an overview of FMEA process. First, you define your scope and team. You start by identifying what system, design, or process you'll be analyzing. Then you map the process or design using visual aids like process flowcharts. Then you identify failure modes through brainstorming. And then you determine effects, causes, and current controls to understand the potential consequences of each failure. Then you assign the SOD ratings, severity, occurrence, and detection, and you score each failure mode. Then you calculate the RPN using the equation S times O times D to quantify the risks. After that, you prioritize and take action according to the RPN which is highest, and finally you will review and update. And FMEA is a living document that goes through constant updates. First step to FMEA is to clearly define the scope of your analysis. So questions that you can ask are you evaluating a full product, sub-assembly, a specific process step? You need to establish boundaries to avoid overcomplicating the FMEA or missing key areas. Then you form a cross-functional team that includes people with multiple skill sets as well as experience and knowledge. Each team member brings a unique perspective, helping identify risks that others might miss, and finally set objectives such as improving safety, reducing downtime, preparing for product launch or increasing profits, and assign clear responsibilities for data collection, facilitation, and follow-up actions. Next step is to map the process or design that you're analyzing. So it could be a manufacturing process or even a system or product. So the goal is to visually represent the full sequence or structure, so the team can identify where failure might happen, what feeds into or results from that step, and the relationships between the steps or part. So use visual aids such as flowcharts or block diagrams to have a better idea of the entire picture. So in step 3, the team identifies all the possible failure modes, that is all the ways a component or system might fail to perform its intended function. So this can be done through brainstorming sessions, historical defect data, and industry standards or field reports. So don't just focus on visible breakdowns, also consider hidden or latent failures such as calibration drift, control software bugs. The key here in FMEA is to be thorough, because a failure mode if it's not listed, it's not going to be addressed. So now, after listing all the failure modes that may or may not occur, the team must analyze 3 related factors, which is effect, cause, and controls. So effect is what is the impact if the failure occurs. It can be local, systemic, or even customer related. And number 2 will be the cause. What could lead to this failure, whether it's human error, equipment wear, inadequate design, or flaws in the system. And then finally is controls, which is what safeguards are already in place to either prevent failure from happening or detect it before it reaches the next step or the customer. In the previous step, the groundwork has been laid so that in this step, we'll be able to assign our SOD ratings to finally calculate the RPN number for each failure mode that was detected. So this step involves evaluating each failure mode using a numerical scale according to SOD, which is severity, occurrence, and detection. So the score will feed directly into the RPN, which is risk priority number. So here is a example calculation for RPN, how it will roughly look like in this template. The highest RPN number can be is 1000, and the high RPN suggests higher risk, because either the impact is severe, or the issue is very likely to happen, or it is hard to detect. And by ranking the RPNs, teams can then identify which failure modes require immediate attention and where their resources and energy and time can be effectively distributed. So once the RPNs have been listed and ranked, we then prioritize and take action. So we first focus on high RPNs with high severity, then implement corrective actions and aim to reduce the occurrence as well as the detection, and then to reevaluate and update scores. And as I said, FMEA is a living document, so it goes for constant reviewing and updating. In this slide, we have a realistic example of an FMEA table. Each row represents a different process step and the associated potential failure mode. We can observe the effect of each failure, the underlying causes, the existing controls, and then how all of this is scored in terms of severity, occurrence, and detection. Now here are the advantages of using FMEA. Number 1 is avoidance of potential failures. Number 2, increased functional safety and reliability. Robust design and stable processes. Cost reduction. Legal protection. Operational efficiency. Communication improvement. And finally, knowledge-based development. Like any other quality tools, FMEA also has its limitations. Number 1 is that it is time and resource intensive. Number 2, it's limited use. Number 3, it may overlook human factors. Then subjective scoring, and does not account for failure interactions. Then potential check the box exercise, and finally the weaknesses of RPN. However, these limitations don't invalidate the tool, but they do highlight the importance of supplementing FMEA with engineering judgment and other quality tools when necessary. As mentioned before, FMEA is integrated into the Six Sigma DMAIC cycle. So in the define phase, FMEA helps identify CTOs, critical to quality aspects, and potential failure points from the customer's perspective. During measure phase, teams use FMEA to evaluate current process performance and highlight where the data is needed. In analyze phase, FMEA becomes a key tool to prioritize failure models based on risk, the RPN number, and guide root cause analysis. So it's even implemented later in improve and control phase, where it helps define corrective actions and becomes a basis for control plans, visual inspections, as well as standard work. So some integration of FMEA with other quality tools would be, it works with a fishbone diagram for root causes, and then it can also be linked to Pareto charts, and then we have control plans and process flow charts, and finally it even connects with DOE, design of experiments. Through this presentation, we now know how powerful of a tool FMEA is, and this makes FMEA a valuable method for both preventing failures and sustaining long-term improvements to a system. So it is definitely a tool to learn and to practice in any kind of process, product development.